In the previous video, we learned about imaginary numbers, and now we want to generalize the concept of the number to the complex numbers. And complex number is nothing more than the sum of a real number and an imaginary number. Okay, so for example, 2 plus j, 5 minus j2, negative 3 plus j7 are complex numbers. And we can refer to each of the parts of a complex number according to whether it's real or imaginary. So we refer to the real part and the imaginary part. Example, we have to identify the real and imaginary part of 2 plus j. Real part 2, imaginary part j. That was pretty easy, wasn't it? Now, you remember that any real number can be represented as a point on a number line, but since complex numbers have two parts to them, we have to use a plane to represent a complex number. And in electronics math, this representation is known as a phasor. Okay, so what is a phasor? It is an arrow drawn from the origin to the point in the plane with x and y coordinates given by the real and imaginary parts of the complex number. Okay, so for example, we want to represent 2 plus j, 5 minus j2, and negative 3 plus j7 as phasors. Okay, so over here on the graph, we see there's 1, 2, and 1. So 2, 1 in the plane, arrow drawn from the origin to 2, 1. That represents 2 plus j as a phasor. 5 minus j2, 1, 2, 3, 4, 5. 2 in the negative direction, that represents 5 minus j2. And negative 1, negative 2, negative 3, and 1, 2, 3, 4, 5, 6, 7. Negative 3 plus j7, there's that complex number represented as a phasor. Now, of course, any real or pure imaginary number can also be represented as a phasor. So, for example, we want to represent 3, negative 3, j3, and negative j3 as a phasor. Then 3 is just going to be an arrow drawn on the real axis, or on the x-axis, from 0 to 3, and there it is. Negative 3 in the opposite direction. j3 on the imaginary axis, or y-axis, and negative j3 in the opposite direction. That's all there is to that. Oh, there's one other thing I want to show you about, which is kind of interesting about complex numbers. We can consider the j as an operator which rotates a phasor by 90 degrees. So, starting with the phasor represented by the number 3, right? That's pointing to here. If we multiply by j, then this arrow rotates 90 degrees up to here. This arrow, remember, represents j3. And if we multiply by j again, it rotates again by 90 degrees to negative 3. And you can keep doing that as long as you wish. And it turns out that multiplying any phasor by j will cause the similar 90-degree rotation.